In this video, we're going to work with absolute values and how you solve equations that have absolute values in them that are pretty straightforward, the linear ones. Now, um, we're going to build on what we've been working with so far. So in the series so far, we've talked about how to solve just regular linear equations, the ones that don't have any visible powers like 2's and 3's and 4's. Everything has an understood power of 1, all right, because it's there one time, so they don't list that, all right? But then we talked about linear equations that were inequalities and how to do that. So I'm trying to also teach you how to study for math. Maybe you haven't had such success in that for a while, or maybe you've forgotten things, and so we're going to try to reinvent the lists. But what you try to do is to learn a series of steps, and then rather than learning a complete different series of steps for the next thing, you try to use what you can already describe and already perform, and then just maybe add a step or two in, or just modify it just a little bit. And then that helps you to learn things quicker, helps you keep up with them, helps you to see the similarities and how things work. So I want to back up for just a second, because in one of the previous videos, we talked about first, how do you solve a linear equation? And the way you solve a linear equation is, we talked about it over and over. You simplify the left-hand side, add your like terms, do the rule of order of operations. Simplify the right-hand side, add your like terms, do the rule of order of operations. Then you isolate your variables on one side. You get all your variable terms on one side. You isolate your constants on the other. Okay, so you split them apart, either side of the equal sign. And then you do whatever it takes to get just an x. You'll hear me call it a 1x. So usually what happens at that point is you multiply or divide by something to go from a 2x to just an x, all right? Now, then we moved on to linear inequalities, and I want to show you how the process was really the same with a few additions, right? So with a linear inequality, we still did the same thing. We simplified the left side, simplified the right side, tried to get our variable terms on one side, tried to get our constants on the other side. But when we got around to the time to solve for just x, and this could have also happened earlier in the situation when we would do things like clear fractions or whatever. If you multiply or divide by a negative, you have to remember to reverse the inequality, because no one's going to remind you but you. And then, of course, we didn't just have an answer like x is 2. We had an answer like x is greater than 2, and then we'd have to graph it, and then we'd have to talk about interval form. And you could add that into your list if you're wanting to see the complete picture. You could talk about how you present your answer to the reader, the different formats or the specific format that your teacher wants. Now, what I want to do is to kind of go back to this solving linear equations. And when we're talking about absolute values, I want to talk about how you solve them. And then I want to try to teach you how you sort of take an already used process and modify it for a new technique. Okay? So let's talk about absolute values. So at some point, they may have asked you, what is the absolute value of 4? And they would show it with these big black lines like that. All right. Now, and you may remember that the absolute value of 4 was 4. Now, what was that? Okay, well, what that was, if you think of 0 as your origin, the absolute value is referring to the distance that you are on this number line away from 0, away from the origin. Well, where could you be? You could be 1, 2, 3, 4 away on this side. That would be a distance of 4. And you could be 1, 2, 3, 4 away on this side, which is also a distance of 4, but its location is a negative 4. So the absolute value of any number is saying, how far are you away from 0? I don't really care if you went to the right or the left. I just want to know how far you went. Or, say I'm going to go looking for you. Where would I start looking? 4 blocks away from 0. All right. So now, the formal definition for this says, if you have the absolute value of some number a, it's equal to a if x is greater than or equal to 0, and it's equal to a negative of a if x is less than 0. Let me straighten that up just a little bit so the way they normally show it in the books, and they'll show it like this. All right, so they have two cases. Now, what does that mean? Okay, so if we're doing the absolute value of 4, now 4 is positive, so it's greater than or equal to 0. And we talked in previous videos about how greater than and equal to doesn't have to be true at the same time. It says greater than or equal to. I'm happy with either one. All right, so 4 is greater than 0, and it says whatever this number is, and here it's positive, and the answer is positive because the distance is positive. If you're asking for what's the absolute value of a negative 4, then this is negative, and you would use this approach, and it's the, let me change this color. Let's look at this negative. So it's the negative of whatever you had in there. Okay, so the negative of a negative 4 is a positive 4 because you are 4 units away from 0. All right? So here we go. So what if I have the absolute value of x plus 1 plus 2 is equal to 5? What we're going to do is try to start off with the steps that we've learned. I'm actually going to erase this up here and put that up there next to where the steps are. Okay, so if we had the absolute value of x plus 1 plus 2 equals 5. Let's see how far we can get, following this system that's over there. So we would simplify the left-hand side. Can we take a 2 that's on the outside of the absolute value bar and add it to anything inside the absolute bar? Gee whiz, it's a tongue twister. Inside the absolute value bar? No, you cannot, because you have to isolate the absolute value bars before you can do anything in there. You're going to see that in just a second. So no, we cannot add inside. We can't multiply inside either. Can't subtract from the inside, can't divide from the inside. So this is sort of like a brick. Okay, we just have this brick right here that we can't touch on the inside until we clean up everything on the outside. So there's nothing to simplify on the left. There's nothing to do on the right either. So let's go down to, let's isolate the variable. Now, in this case, you're not isolating the variable. What you're going to do is this part right here. You're going to isolate whatever's in those absolute value bars. And some people just isolate this, all right? Or you could spell it out, absolute value bars and whatever's in them. Okay, so this is going to change to here. Now, if what I'm trying to isolate is this part right here, I'm trying to get that brick, okay, of the absolute value bars isolated. That means the 2 cannot be on the same side, right? How do we move or get rid of a 2 that's being added? You subtract. So you would subtract 2 from both sides, and you would have the absolute value of x plus 1 is equal to 3. Now, so this brick that can't be touched at is isolated, and I have my 3 on the other side. Now, what it's actually asking you, so I want to kind of draw a little initial graph that talks about what you're imagining, all right? It's saying to me, all of the math things are like little people, okay? So there's somebody whose name is x plus 1, right? And where is x plus 1? They are 3 units away from 0. Okay, so where could they be? They could be over here at this 3. or they could be over here at this 3. Not that I drew that to scale. All right. So if I went looking for them, I would go 3 units to the right or 3 units to the left to find x plus 1, whatever they're up to. Okay. So what does that look like? Right. X plus 1. Now I take it out of the absolute value bars. Could be at -3, or, so these turn into an or. X plus 1 could be at 3. So this is going to turn into 2 equations, and then we solve them. So we do the same things we've always done in order to, now we're going back to the original list that says simplify the left, simplify the right, get your x's on one side, numbers on the other. So we'd subtract 1, and you would have x is equal to -4, and we would subtract 1 over here. And from this one, we would get x is equal to 2. All right, I don't know that I'm believing that. All right, let's check. So let's go back up here and check it. Check x is equal to -4. So we would go, is the absolute value of -4 plus 1 plus 2, is that going to be equal to 5? Okay, the absolute value of -4 plus 1 is the absolute value of -3. The absolute value of -3 is 3. And sure enough, 3 plus 2 is 5. So that's a check. Okay, let's check x is equal to 2. The absolute value of 2 plus 1 plus 2 equals 5. I don't know about that. The absolute value of 3 is 3. And 3 plus 2 is indeed 5. Okay, so they both check. So these are my answers. So let's think for a second. All right. If we have an absolute value problem, what we do is we simplify the left if we can. Okay, simplify the right if we can. Get our, instead of the variable by itself, we get the absolute value entity by itself. Get the constants that are outside the absolute value to the other side. All right. And right here where it says solve for x, okay, that's just a little tiny difference, because instead of just typically solving for an x, okay, we have this little or situation here. All right, so what we're going to have to add in here is that to solve for x, by setting up the two possible, and I call it the two possible locations. This is your list. You call it whatever you want, okay? And then you're going to solve this, all right? And then if I was you, I would go back and check all these answers, because if you check it and find out you made a math error, you save the points your teacher would have taken off, or you save the points that the computer would have taken off. And every point you save now could be a point that you're trying to save when you get down to the final. So save them now, okay? Now, so you see what we did? All right, let's try another one. And what you would normally do is you would come up with a list like this one. You think, I think this is my list. And then you try a couple more problems. And then you find out maybe you have a common error. You keep forgetting to do something. So that writes into your list, right? So you write, don't forget to do this. Please don't do this anymore. Okay. Big star every time you mess it up. Okay. And so you add to your list whatever you need to do in order to keep yourself on track. All right. So let's keep trying this out and see how we're doing. Let's try one that's a little bit more difficult. So what if we have 3 times the absolute value of 2x minus 4 minus 6 equals 9. So let's try that list on for size. And I'm going to say it to you. But normally you would write it and set it down next to your problems that you were working on and keep looking back at it, trying to memorize it, because you won't be allowed to bring it in on the test. All right, so you memorize it. So we say, okay, I'm going to try to simplify the left. You cannot add or multiply inside, from the outside to the inside of an absolute value bar. So I can't take 6 away. I can't multiply them by 3. So I'm moving on to the next part where I'm going to try to get the absolute value bar entity, okay, by itself. So the first thing I want to do is to get this by itself, and then I'll get rid of the 3. Okay, so how do you move or negate something that's being subtracted, you add it. Okay, so you would add 6. Here in a little bit, I'm going to stop showing you those steps and just say them to you so that you can get used to skipping some of the steps. You put in as many steps as you want. I'm assuming that if you're out here looking at this, you just don't understand what you need to do. So I'm putting in all the steps so that it kind of builds some confidence. Okay. Keep in mind also that in the description that's down below this video, there'll be a link to some practice problems with solutions for you to play with. And then there's the link to the next video and the previous video. So we're down here. We haven't quite isolated it. I need to get rid of the 3. The 3 is multiplying. So the opposite of to multiply is to divide. And what you do to one side, you do to the other side. So now you have 2x minus 4. Because these 3's cancel. This is 5. All right. Now, to kind of, you don't have to do this. And in fact, I'm not sure your teacher would quite understand unless they demonstrate it this way to you, what you were doing here. But this is what I do. Inside my head, I'm thinking, okay, I have a different person. This person's name is 2x minus 4. And if I went looking for them, all I know is they're 5 away from 0. They could be down here at this 5. They could be down here at this 5, which is the negative 5. All right. But I just know they're in one of those 2 spots, and I'm going to go looking for them. Because like I said, in order for me to kind of, and I'm not trying to brag on myself, but I've got 3 engineering degrees, and I have stayed sane by making up stories for my math things so that I can keep track of everything. And I've taught math for 30-something years. There's nothing wrong with making up a story to keep yourself entertained while you're doing your math. All right. So where could 2x minus 4 be? 2x minus 4 could be down here at the negative 5, or 2x minus 4 could be up there at the positive 5. I don't know where they are. So then I'm back to the original list of how do you solve a linear equation. You simplify the left, simplify the right. Nothing to do on this first one. Isolate your variables. So you're going to get rid of the minus 4 by adding. And you would have 2x is equal to negative 1. All right. And then you want to know what x is. So I need to negate or do away with the 2, and it's multiplying. So I'm going to divide because that's the opposite. And x would be minus 1/2. So over here on this second one, I can't do anything to simplify anymore on the left or the right. So I'm going to isolate my variable by negating this minus 4 by adding 4 to both sides. 2x would be equal to 9. I want to know what x is. X is 9/2. And you can check all these. Let's check one of them because a lot of times we don't work with fractions very much. You need to check it into the original equation before you mess with it. Don't check it into one after you've cleaned it up because that just says from this point down, you have not made any errors. But you don't have any verification that from here to here, you didn't make an error. So if you want to know if your answer is totally correct, you're going to check it all the way back up into what the teacher or the book or the computer gave you to solve. Okay, so we're going to check x is equal to negative 1/2. All right, so does 3 times the absolute value of 2 times negative 1/2 minus 4, is that equal to 15? 3 times the absolute value. These 2's cancel. Negative 1 minus 4. Does that equal to 15? Does 3 times the absolute value of minus 5. Now remember, you can't multiply inside an absolute value. You have to solve it first. So the absolute value of 5, negative 5 is 5. Now you can multiply. And that's a true statement. So yes, this checks. And if you check the other one, you'll find out that these both check. It's a terrible box. Okay. But I'm freehanding it. All right, let's do another one. What if we have -7 minus, oh, scoot that up a little bit more. -7 minus 3 times the absolute value of 4x plus 6 equals -19. I wanted to have one that was a little bit more complicated. So you cannot take -3 away from -7. All right, remember the rule of order of operations, parentheses, exponents, multiplication, division, addition, and subtraction. So this 3 is saying, I would really like to multiply by whatever's going on in here. So you have to multiply that before you can subtract it from 7, right? But it is so tempting, okay? So tempting. So what you have to say is, I'm going to resist temptation, and I am going to add 7 to both sides. So I'd have -3 times the absolute value of 4x plus 6 equals -12. All right. So then you say, all right, I'm still working on isolating my absolute values. So I'm going to divide by -3. And you would have the absolute value of 4x plus 6 equals 4. Now, I'm going to try to not draw the initial statement that reflects what I'm actually thinking. I'm going to try to think it. Okay, so here's a different person who's 4x plus 6, and where are they? They are 4 away from 0, and they could be 4 to the right away from 0, and they could be 4 to the left away from 0. And so 4x plus 6 is equal to 4, or -4. 4x plus 6 is equal to 4. Now, there is absolutely nothing wrong with your teacher saying, okay, remember the definition of it's either A is equal to A or it's equal to the opposite of A, depending on technically which side of 0 you're on. And so it would be just fine for your teacher to say 4x plus 6 is equal to A or equal to the negative of A. But in my world, all right, that's kind of an abstract theory, and theory is okay for me, but it doesn't make me smile, okay? So maybe having this picture of going and looking for somebody will help you hang on to this if the theory is not ringing a bell with you, right? And to be honest, for most of my students, that would not have stuck. Okay, the story would stick, okay, but this, it's equal to A or the minus A, they would do it, but they wouldn't really understand. And I think saying you're going to go looking for somebody at some location actually explains what it is you're doing. All right. So we're going to do an or on both of these and treat them separately. So we would subtract 6 from both sides. And I'm going to work this one on this one so I don't have to change pens again. So I'd have 4x is equal to -10, or 4x is equal to -2. Then we're going to divide by 4 so that I can get x by itself. And you're more than entitled to work these at the same time, just as long as you keep track of what you're doing. So x is -10 fourths, which reduces to -5 halves, or x is -2 fourths, which reduces to -1/2. And these are your answers. Alrighty. Now, you don't always have two solutions, okay? Sometimes you try to think about it as two solutions, but sometimes you don't. So let's see a couple of cases. So here's 5 minus 2, x minus 4 equals 5. Now again, you cannot subtract 2 from 5 because 2 is multiplying, and you have to do that before you can subtract something. So we're stuck right now with this 2 just being stuck as multiplying the absolute value. But I can get rid of this -5, or this 5, by subtracting 5. So I would have -2 times the quantity of absolute value of x minus 4 is 0. You would divide both sides by -2 because you cannot set up these two cases until the bars are absolutely isolated, which means they can't even have anything multiplying them. All right. So Where is x minus 4? Well, technically, if you followed the rule we had been doing, it would look like this. But what is a negative 0? It's just 0, okay? So you get x minus 4 is 0, so x is 4. All right, so sometimes you just get one answer, and sometimes you don't get any answers. So let's look at this one. The absolute value of x plus 4 is equal to a negative 5. Now, you never take the absolute value of a number and get a negative out of it, okay? Because we're always asking for the distance, and the distance is assumed to be positive, right? So now you can change it, if you had to like the absolute value of negative 3 and had a negative out here, the absolute value of negative 3 is 3, and this negative is still there. So this would become a negative 3, but only because you didn't fully isolate it, okay? So can you take the absolute value of a number and get a negative number from it? No, right? That's never going to happen. So this has no solution. And students go, oh my goodness, can you put all of these on the test just like that? I go, no, we can't do that. All right. And yes, can you look at it and tell that it doesn't have any answer if it's equal to a negative? Yes, but only if it's fully isolated where the absolute value bars are. Because look at this one. What if you have the absolute value of 3x plus 1 minus 7 equals negative 4? I mean, there's a lot of negatives there. It seems like you should be able to go, can't do an absolute value equal to a negative, but you cannot decide that until after the absolute value bar entity is isolated, right? So I need to get rid of the minus 7. So the opposite of to subtract 7 is to add 7. And all of a sudden you have the absolute value of 3x plus 1 is equal to 3. So see, it's really not equal to a negative. It's equal to a positive. So you have to continue working this one. And you would have 3x plus 1 equals 3, negative 3, or 3x plus 1 equals 3. So you would subtract 1 from both sides. 3x is equal to negative 4. Subtract 1 from both sides here. 3x is equal to 2. So divide both sides by x. X is negative 4/3. And I'm skipping steps on you. How you doing? Divide both sides by 3. So I skipped 2 steps in there. Are you okay? Now, if you need me to go back in there and put them in so you can see what I did, I subtracted 1 from both sides. Right? And I divided both sides by 3. Right? Okay. So put all those steps in there if you want them, and if they make you accurate, hey, a little slower and correct is much better than fast and wrong. Okay? So you're getting the hang of this? So how's our list looking? So I think our list is doing pretty good. Let's go all the way back up here. Way back up here. Okay. Simplify the left. I think that's working. Simplify the right. Okay. Isolate the absolute value bars. Okay. On one side, which means any numbers that are outside the absolute value bars have to be negated or gotten to the other side. All right. Solve for x. All right. And this is by setting up the two solutions. Now keep in mind that sometimes you don't actually have two solutions. Okay. So you might want to say, not you might want to write a note saying not always two solutions. And give examples. You could say the absolute value of something equal to a negative is 0 with a slash through it, as long as you remember that it has to be isolated. Okay, so this is your list. You add whatever notes you want in there. All right. And if our list is a good list, we should be able to do a problem that looks kind of like this. And keep in mind, because I don't know what, when you fell into this video series, If you make your zeros like this, like some people would say this is 100 and they put zeros in there, like military people, computer programmers often do that. Some people just picked that up along the way. That is not zero in math, okay? That is empty set, okay? This is no solution, empty set. So if you're trying to tell me zero, if you're trying to say, oh, the answer's zero, and you say, oh, the answer's zero, I'm going to count off points going, there's an answer, it's zero, all right? So don't use that for zero in a math class, all right? What if you have something like the absolute value of 2x plus 3, and I'm making this up, is equal to the absolute, how about I write this out? 2x plus 3 is equal to the absolute value of x minus 1. Okay? That's a little weird. All right. So let's see how we're doing. All right. Now, have we isolated the left side as far as absolute value goes? Yes, and we can't do anything to simplify it. And, oh, this is weird. We have an absolute value on the right side, but it's isolated and there's nothing to do. So this is a little weird, my analogy about I'm looking for 2x plus 3, okay? Where might they be? Well, it kind of goes like this. 2x plus 3 could be at the opposite of where x minus 1 is, okay? Or 2x plus 3 could be in the same spot x minus 1 is, okay? So they could be opposite each other or they could be on the same side, all right? So 2x plus 3 is equal to negative x. This distributes plus 1, right? Now you get your x's on one side, so we're going to add x to both sides. So 3x plus 3 is equal to 1. Then we're going to subtract 3 from both sides. So 3x is equal to negative 2. So x is negative 2/3. Okay? Get our x's on one side. So x plus 3 is equal to negative 1. Get our constant on the other side. So I'm thinking x is minus 4, x is minus 2/3. I don't know. Okay, so when you do this on a test, let's say your teacher did this to you, you would put these and check them. Let's check the minus 4 one first because it's kind of like not as intimidating. All right, so we're going to substitute them into the original. So x is a minus 4. I say that not because it's intimidating necessarily to me, but because my students always talk to me and they always shared about when they'd start kind of backing up, like, oh man, I don't really want to do that problem. And it's usually, it's usually when it's fractions. Okay, 2 times negative 4 is negative 8. And negative 4 minus 1 is negative 5. So the absolute value of negative 5, is that equal to negative 5? Yeah, it is. Okay, I'm good with that one. So let's try, now that we've warmed up, checking the negative 2/3. So is the absolute value of 2 times negative 2/3 plus 3 equal to the absolute value of negative 2/3 minus 1? Right? So it's the absolute value of, now these don't cancel, this is 2 over 1 times negative 2/3 is negative 4/3 plus 3. Now to add 3, I need a common denominator. So 3 over 1, to get it to be thirds in the bottom, we would multiply it by 3 over 3. So this would be 9/3. So this is 9/3. Does that equal negative 2/3 minus, okay. Now 1, to get it to look like thirds, we would multiply by 3 over 3. So it's 3/3. All right. Negative 4/3 plus 9/3 is 5/3. And negative 2/3 minus 3/3 is negative 5/3. And so 5/3, okay, is equal to 5/3. So they both check. So my answers are x is minus 2/3 and x is minus 4. So do you see how we developed a list of rules, okay, for how to do these based on something we already knew how to do? So keep in mind that this list is your list. It's whatever you think and the words you want to use and your trouble spots and your good spots, and the encouragement that you need. But keep in mind that you're building on something you already know. You're not learning a whole new list from scratch. You're just altering a few of the steps. All right. So we're going to simplify the left side, simplify the right side, isolate our absolute value bars by shifting all the constants and numbers over to the other side that are outside the absolute value bars. Then we're going to solve for x by typically, not always, but most of the time, having two possibilities. All right. And then we're going to solve what we have, and then we're going to check. But if we're lucky enough and the teacher wants to give us a smile, they can always give us something that looks like this, but you can't decide if it's no solution until the absolute value entity is isolated and equal to a number. Okay? And then you can say it's no solution. Alrighty. Now, the next video is going to be absolute value inequalities. So it's kind of a step up, but I still think we can use this list right here, and I'll type it up. And we'll do a new version of that list and see how we can modify it to do absolute value inequalities. And, we may actually have to borrow this part right here and use it in the list that's about inequalities. So see how you're taking two lists you already know and kind of making another one? All right. See you in the next video.